We're now going to examine the Pythagorean converse, but let's for a moment look back at Pythagorean theorem. The Pythagorean theorem is for when we have a right triangle and need to know side lengths. Or rather, we need to find side lengths. We need to find the side lengths. So that means if we have a right triangle, then we can find the side lengths. Well, how do we say that backwards? If we have a right triangle, we need to find the side lengths. How do we say that backwards? Remember, converse means we flip it. So what's the reverse of that? We know the three side lengths, and we need to know if it's a right triangle. We don't know if it's right when we're using the Pythagorean theorem, Pythagorean converse, but we know the three sides. So the converse works just like any converse works, starting at the end. If we do c squared and then a squared plus b squared, and we get that it's equal, then we have a right triangle. Then the triangle is right. Now, if c squared doesn't equal a squared plus b squared, the triangle will not be right, but we can do better than that and be a little bit more specific. If we do c squared and compare it to a squared plus b squared and get a greater than, c squared is bigger. Imagine what that's going to do to the angle that was a right angle. Meaning, take a look at this picture. If I have C and I make it longer, well, what do I have to do to these two sides A and B? They're still going to connect here, but now it has to reach out here and out here. Well, what did I do to that angle? I made it larger than a right angle. So then the triangle is not a right triangle. Now it is obtuse. Let's think of it the other way. If I do c squared and compare it to a squared plus b squared, and now the c squared is less than, well, what happens in that case? So now I'm going to make c shorter. That way c squared can be smaller. And look what happens when I connect with the other sides. There's my a, there's my b, so this angle is smaller. So less than, c is smaller, think smaller angle, then the triangle is acute. Now we're mostly going to be emphasizing when the triangle is a right triangle, but it's helpful to know what it is if it's not a right triangle. Let's look at some examples. Classify the triangle as right, acute, or obtuse. Now, remember when we were doing Pythagorean theorem, and the biggest number is always the hypotenuse, and the hypotenuse is c. C is the biggest number of my three numbers. So of these three numbers, 12, 16, and 20, I see 20 is the biggest. Now hang on a minute, because I don't have to always use the Pythagorean theorem or the Pythagorean converse. If I recognize that I have a triple, then I save myself time. Is this a triple? Well, we did this one earlier. The 3, 4, 5 triple, multiply 3 times 2, 4 times 2, 5 times 2, 3 times 2 is 6. Nope. Okay, so not multiply by 2. What can we multiply by to get 12? How about 4? So multiply everything by 4. 3 times 4 is 12. 16, 5 times 4 is 20. That's a triple. Triples satisfy the Pythagorean theorem. Therefore, I know it is a right triangle because it came from a triple, and only triples satisfy the Pythagorean theorem. Now, I know this one's not a triple because it has a radical. Now, square root of 56 looks like it's bigger than 9 because 56 is a bigger number. But if we type in square root of 56, we see that this is not bigger than 9. In fact, we can do it like this. 9 squared is 81, so we can kind of think of 9 like square root of 81. That's bigger than square root of 56. Or type this in and see that this is approximately 7 point something. Anyway, 7 point something is smaller than 9, so 9 is my C. Always pick the biggest one to be the C. So C squared, leave a blank, compared to A squared plus B squared. 9 squared, leave a blank, 5 squared plus square root of 56 squared. 81 compared to 25 plus, remember when we square a square root, they cancel out, and it's just that number. 81 compared to 81, that makes equals, therefore, right triangle. Would you like to try the next two? Come back and see how you did? Give it a shot. You'll check your answers after the break. So how'd you do? Did you get them right? One more. Graph the triangle. Find the lengths of the sides. Then use the Pythagorean converse to classify the triangle as right, acute, or obtuse. Let's start by graphing the triangle. E is at point 0, 0. Every time we plot a point, let's label it E. F, 2, 4, 2, 4 is F, and G is 6, 2. 6, 1, 2. Here's G. Now, we can look at it and possibly even make a guess for what kind of triangle we think it is, but that's not what this said to do. This said, find the lengths of the sides. We'll do that first. Coincidentally, we're using Pythagorean Theorem to find the lengths. Remember how we do that. From E to F, how much do we count up and over? Because remember, that makes a right triangle, where the hypotenuse is that slanty length from E to F, because there is our right angle. So how much we count up? 1, 2, 3, 4 blocks. How much we count over? 1, 2 blocks. So instead of having to write C squared equals A squared plus B squared, we're going straight to what C equals. So take the square root away from there and put squared away from there to take the square root over the other side. So we're doing square root of 4 squared plus 2 squared. So that makes 16 plus 4, or square root of 20. If we simplify that, that's not a perfect square, so that's 4 times 5, or 2 square roots of 5. Let's find the other two lengths, F to G and E to G. F, G, and then E, G. Again, let's make it into a triangle. Count how much up and over, and that will be our hypotenuse, our C, because there's the right angle. So up 2 blocks, 1, 2, 3, 4, over 4 blocks. So square root of, again, 4 squared plus 2 squared. Now when I get the exact same numbers, I don't have to do all this work again. I know I get square root of 20, which is 2 square roots of 5 when I simplify it. Last one, from E to G. We'll turn that into a right triangle and we'll count 1, 2, 3, 4, 5, 6, and 2. So we're going to do square root of 6 squared plus 2 squared. Remember, adding means the order here doesn't matter. So this is going to make 36 plus 4, or square root of 40. Again, not a perfect square, so we can write it as a perfect square times another number, so 2 square roots of 10 for our answer. So I have the lengths, 2 square roots of 5, 2 square roots of 5, and 2 square roots of 10. Now I need to classify the triangle. So now I'm going to do C squared blank, A squared plus B squared. I want to see, is it a right triangle? Now, I know I simplified these 3 side lengths, but it's going to be easier to use the non-simplified version of my answer. The largest of these 3 numbers is the square root of 40, so we'll put that in here. Square root of 40 squared, blank, square root of 20 are the other 2 sides. Remember how squared cancels out square root. And I'm left with 40 blank, 20 plus 20, and 40 compares to 40, and they are equal. Therefore, this is a right triangle. When I get equals, I have a right triangle. Take a few moments to write a summary. Let's do a comparison. What is the difference between using the Pythagorean theorem and the converse? Maybe you attack that question this way. What do you want to find when you use the Pythagorean theorem versus what do you want to find when you use the Pythagorean converse? Again, explain in a few words or sentences what is the difference between using Pythagorean theorem and Pythagorean converse. See you in class.